Hello everyone. I will give you a Multisim tutorial today. This is the workspace. It should show the grid automatically, but if not, you can go view and click on the grid. So we want to start with the DC analysis. So we're going to have a DC voltage source and bunch of resistors. This icon is where you place voltage sources, and what we usually choose is the DC power source and the AC power source in our labs. For the time being, we have the DC power source. We click OK and it's automatically placed. It also automatically opens the same window again. So make sure to include the ground symbol. Your circuit will not work unless you place the ground symbol. And then we can close this. So we got our DC source, and I can set any value I want. Just simply type in, and then you can give a label that you like. Then we have we're needing two resistors, so we click on this place basic components and select a resistor. Do not worry about the value of the resistor, you can always change it. So when I click on it, just place it, and I can just double click on it and the value can be set to anything you want. And if you don't specify any, it will be in ohms, but this one is in kilo ohms. So we could have also said 1200 instead of 1.2K. Now I need another resistor. I could go to same box again, but I can also copy. So Control C and then Control V, and it places the same thing, giving a different name. I want to rotate this, so you can right click and click rotate. But I can also do Control R, and it's gonna rotate quickly. To connect, you just go to endpoints and just drag the line. And then it is very important you have this ground, otherwise you're gonna have an issue. And make sure you got this dot whenever you have three components. You can move this around and it doesn't look like a nice one. I'm gonna zoom in and then try to rewire this thing. I can delete. So once you draw this line, you can always drag it. Now it's looking better. So we want to make this maybe a different number, 2.4K. So my goal is to measure voltage across the 2.4K. And the easiest thing to do is just go to this voltage probe. Now there are two kinds. This one just measures the potential. So you just place it to the node of interest. And then now I want to move this down, so I can do Control A and then use the down arrow. Now I'm going to click this triangle, and it's just going to display automatically how much voltage I have here. It's 6.67 volts. Now this is with respect to ground automatically, but if you're wanting to measure the voltage across 1.2K, see, you cannot use this. So for that, first you need to stop the simulation before you do any changes. So I'm gonna put a differential probe across R1. So I go to this one right here. So it expects you to place it at two different terminals. So this is the positive, this is the negative terminal, or the reference. So it's gonna measure with respect to this point as the reference. So when I click simulate, it just shows me that it's 3.33 volts across 1.2 and 6.7 on this. So it is expected if you do a voltage division, you're gonna get these numbers. Now For this one, you could have used the differential probe as well, although it's not necessary. It should show the same thing. And often we want to measure the current. So I'm just going to place another resistor here, Control C, Control V, and maybe make it 4.8K. So I place it in parallel. So assume I'm interested in getting the current going through 4.8K. Now you can use the current probe. Just place it on the branch of interest. So when you run, it is going to show 1.19 milliamp right there. To avoid crowding, I'm gonna delete this voltage probe. So I want to now measure the main branch current and also this branch current right there to see if I can prove the KCL theorem. So I think I placed it in the other direction, so it's just showing negative, so I can place it here instead. Probably it just like to have it this direction. So when I click on run, it just shows me the main branch current is 3.57 milliamp, which is sum of these two. So I'm kind of proving the theorem. Now before you take a screenshot, you may want to move this around if you like. So this is easiest way of measuring voltage and current. Now there is also instruments that you could use. Although it's cumbersome, you can use a multimeter like this one to measure a voltage or a current. If you're measuring a voltage, you have to put it in parallel. So this is gonna now measure the voltage across the parallel circuit. This is the voltage across these two components. Click run and double click on the multimeter so it shows you how much voltage it has. And similarly, you can place another one, but you have to first stop the simulation, and then you place another one here. Make sure you select the one that you're measuring is a voltage. When you hit run, double click, you see the voltages across these two components in series. The sum should be equal to the 10 volts, which is actually the verification of the Kirchhoff voltage law right there. So I don't think this is necessary as we have the probes right there. Now if you're willing to measure a current, you have to insert it in series. You need to break this and then you put this ammeter here. So it needs to be in series. Never place an ammeter in parallel. So when you click on this, you select the ammeter position. When I hit run, it measures the main branch current. And this one is of course the voltage. So you want this to be the current of 4.8. Then what you need to do is to insert this in series. So I need to break this. If I want, I could also broken this one, but we better use this one because it's kind of easy to see, and you can move this around so it looks nice. I'm gonna move this using arrow on the keyboard. When you hit run, oh, hold on, I need to put this into ammeter position. So you can see how the currents are measured using this tool, the multimeter tool. In circuits classes, you will also use AC voltages. But before we go there, I want you to save your work somewhere that you like. Just give it a name. It's not necessary for running, but if you want to later reuse it, then it's probably a good idea to save it. So right now what I'm going to do, some modifications so that it can measure waveforms. So here I'm gonna remove this, just select and delete. Now here we use the other one, which is the AC power source. So this is the one that you have in the AC outlet. So it automatically uses 120 volts that you have with 60 Hertz. So I'm reconstructing my circuit. It's the same resistors. So my goal is to able to see waveforms on this one. Now you double click on it and there are various fields you can change. I can change this to 10 volts RMS. Now the peak-to-peak value is going to be 14.1. So it will toggle between 14.1 and negative 14.1. So you will see AC signals, AC sources, I think, in this lecture later. The frequency can be set, so I'm changing it to 100 Hertz. And you can name it if you like. So this one can be Vin. Now you may want to also name your output node, because this is where we're gonna look in the oscilloscope in the AC analysis. When you name a node, make sure to click on this one, show node net name, and you can choose any color you want. Apply. Okay, so node naming is critical, especially in AC with respect to AC inputs. Now the best thing to view waveform is AC analysis. So you go to simulate analysis. Now this window might be a little different, but you always go to analysis window and you choose transient. So the transient window is where you set your oscilloscope parameters. So this one is having a period of 0.01 second. So you may want to adjust this to maybe 0.02, like you can see 2 cycles. And you may want to, in the next tab, specify what you want to measure or observe. And this is the V out that we are interested. So we click add. The next thing is to just run. And it nicely shows the output waveform. And if you like, you could also plot input and output simultaneously. So I can put, I think we didn't call it, it should show V in. Probably it's using this one. When I hit run, it's now showing my output versus input. I think we named it, name this one, but not this net. So this net, let's call it V input. So it's gonna be clear when you wanna do AC analysis, those variables are right there. So both of them are displayed, both nodes, and I'm plotting it simultaneously. When I hit run, it just gives me this nice waveform. What you should immediately do is change the background. I don't know why it's given in black. Change it like this. What you may want to do is also put cursors and grid. So this is the grid, so it looks nicer. and the cursor. So the cursor is needed so you can see the maximum values. So this one is the second cursor. So as you move this, you'll notice it is actually displaying the values of both. So the maximum here is Y2. So it's 14 volts for the input and 8 volts for the output. So you can easily see. So it's roughly 14 and 8. So you can put the second cursor. So what this does is it shows the minimum. Now you're able to observe the peak-to-peak value from delta Y. So it's telling me that input is 28 volts peak-to-peak. So it's measuring between these 2 points. And the input, the output is 16 volt peak-to-peak. Now if you want to measure the period, so you may want to go move this thing. So you can actually now see that delta X is like 10 millisecond. So you see that this is gonna correspond to 100 Hertz that we originally set. Another alternative to transient analysis is to use the oscilloscope tool. Although I don't recommend using it, I'm just showing it so you have an idea. So you just place the oscilloscope tool from one of the tools. It has 2 channels. Let's connect channel A to input node, and then minus always goes to ground. And channel B plus goes to output, and minus goes to ground. And what you simply need to do is just click on run and then just double click on it like the multimeter. So it just shows you the 2 waveforms. In order to make this just click on the single, so it's just gonna stop. Now you don't have a lot of control here unless you go view show grapher. Then you can kind of change some stuff and make it look like the transient analysis, but I'm not gonna go through this. So simply this is for your information, and the best thing would be to not use this and simply refer to the transient analysis, because that one has a lot of gives you a lot of control. You can specify the waveforms, and here you can select the end time. So that's very important, otherwise you won't get a nice. So if I select 0.05, it should show me 5 cycles. I can just manipulate these cursors and get what I need. So this is the way to go. All right, thank you very much.